Here's a very interesting trigonometric product that we're going to look at. And this might be something that you want to try if you're studying trigonometry, maybe as part of your IB program. So if you feel comfortable with trigonometry, if you think you know it well enough, then give this one a go. And if you'd like to see anything similar to this on the channel, or if you have any recommendations for problems, let me know in the comments. So this product is essentially cosine of x, and then we have times cosine of 2x, and so on. So each term has another 2 multiplied in it, basically. So the arguments of each cosine is so the arguments are part of a geometric sequence, right? So we have basically the first one is 2 to the 0, then we have 2 to the 1, then 2 squared, all the way to 2 to the power n, okay? And it looks quite intimidating because, well, it's a really long product and there isn't any obvious way of dealing with this. For example, one thing you might try is trying to group the terms together. So if you group those and then group the next two and so on. But because of this geometric progression, things are not going to become simpler, okay? And another thing you might want to try, or another thing you might try, is grouping the terms, the first with the last, and then the second with the second to last, and so on. But it actually turns out that there's a relatively simple way of doing this. And the trick here, which is not too obvious, is to multiply everything by sine x. That's it. So if we multiply both sides by sine x, this is what we get. So we get p times sine x is equal to sine x cosine x, and then we have the rest of it. So we have cosine of 2x. I'm not going to write the brackets anymore, but you get the idea. So this is cosine of 4x, and the last one is cosine of 2 to the nx. So when doing this at first, I don't think it's very obvious why this actually gets simpler, but it does, because what you can now do is take those two terms, the sine x and the cosine x, and write them as 1 over 2 sine of 2x. Okay, and just a quick note, sine of 2x is just sine of x plus x, and you can use the sine of a plus b to figure out what this is, but this is just 2 sine x plus x. Okay, so we have 1/2 sine of 2x, and then we have the rest of it, which is cosine of 2x, cosine of 4x, all the way to cosine of 2 to the power nx. Okay, and now we have those two. So now we have sine 2x, cosine of 2x. So let's see what those are. So we have p sine x equals, so we have 1 over 2. And then if we multiply sine of 2x with cosine of 2x, we get 1/2 sine of 4x. Okay, again, using the same principle as what's written here in blue. And then this is multiplied with cosine of 4x, all the way to cosine of 2 to the nx. Okay, and once again we have this. So I'll do it one more time, but then we will look at what the pattern is. So this is p sine x equals 1 over, so this is going to be 1 over 4 times again 1 over 2 sine of 8x, and the next term in the cosine sequence is cosine of 8x, all the way to cosine of 2 to the power n x. Okay, now this here is just 1 over 8. So if we keep this going, and you can actually prove this with induction if you want, but I'm not going to go that route because it's just going to take some time, but it's very easy to do. This will turn into p sine x equals, so basically here's the pattern. We have 1 over 2, and when we have 1 over 2, the next two terms are sine to x, cosine of 2x. When we have 1 over 4, then we have sine 4x, cosine 4x. If we have 1 over 8, the next terms are sine 8x and cosine of 8x. So when we have cosine of 2nx here, so when we have sine of 2 to the power nx cosine of 2 to the power nx, then in front of that, the fraction will just be 1 over 2 to the power n. Okay? And this is something that you can prove with induction, but I'll just treat it as something that you notice by inspection. Okay? So if we do this thing one last time, if we use that sine a or sine x cos x thing one last time, then this will be p sine x equals 1 over 2 to the n, and this will be 1 over 2 sine of, and then we have 1 plus the other, which will just be 2 to the power n plus 1 x. Okay, so this is finally turning into 1 over 2 to the power n plus 1 sine of 2 to the power n plus 1 x. So the product that we started from can just be found by dividing both sides by sine x. So this is sine of 2 to the power n plus 1 x over 2 to the power n plus 1 multiplied by sine x. Okay, and that's what we get. So it turns out that this actually has a very compact form, which you can see here, and it's easier than it actually looks. And all you have to do was just multiply both sides by sine x, and all those terms, so the entire product comes crumbling down like some dominoes. And that's the end of the question.